All right. Oh, you know what I forgot to do? I forgot to put the section number on there. We usually do that before. What is it? 8-4? Pushed the wrong button. 8-4. Okay.
We just wasted 15 seconds.
Yes, we did. That's okay. Nobody watches anyway, so who cares? All right. So, yeah, I know. I want one of my math videos to go viral or something. It's probably when I yell at one of my classes or something. That's probably that's the one that'll go viral and it'll get me fired and everything else. All right. Because there was another. I just saw a video. It was on the news, but apparently this math teacher who was a very well respected, taught for 20 some years in his school, but I guess he referred to this girl with the B word, and somebody had it recorded, and it got on the news, and they're talking about firing him and all this stuff, and yeah, it was on the regular news. Yeah, it wasn't just on YouTube, but so. It was a Pencader. That's right. Yeah, it was that guy Pencader. But the students kind of actually rallied around him and said that we don't want him to be fired because he's a good teacher, and so he made this mistake and all that. And he apologized and all that kind of thing. But anyway, you got to be very careful when you have a living. When you make a living, when you talk most of the day, you have to be very, very careful of the things you say. Because it's easy to slip. Did it rhyme? Okay, good. All right, let's do this. Now we've wasted a minute 30. So here we go. Again, right triangles, because the whole chapter is about right triangles. And now especially, you really got to be careful what you say when you record every single lesson that you teach. So that's right.
Remember when you had to delete the recording because you didn't want
Yeah, I've deleted a couple, but I never say anything. I never say anything bad to delete anyway. So, all right, here we go. Let's take a look at this right triangle. Let's try to go through this as quickly as we can. I know you've had this stuff before, but it's we've learned a couple special triangles, right? We had 45, 45, we had 30, 60, 90. But what if we have something weird? What if we had like a 53-degree angle? Do we have a special formula for 53-degree angles and that kind of thing? No, we don't. So we have to figure out another way to figure out some of the lengths and all that kind of thing of this. Yep. And I know you've been taught this before, but we're going to go through it one more time. Let's see where I want to start on this. Okay, so what we're going to do is this. First of all, I'm going to introduce a letter to you. Is everybody listening now? Up here. Thank you. I'm going to introduce a letter to you that I don't know if you taught that or if you learned that in middle school or Algebra 1 or not, but it's this letter. You ever see that letter? Yeah, it does look like the Oriole O, but it's a Greek letter of the alphabet. Ah, see, there's something you didn't know before, right? It's called Theta. You ever hear that? You ever see people with like fraternity and sorority sweatshirts or T-shirts and stuff, and you see these Greek letters on them? This is a common Greek letter you might see on there. It's called Theta. It's a Greek letter of the alphabet. What that Greek letter of the alphabet represents is just basically, it's kind of a universal thing for an unknown angle. So if you have an angle that you don't know, you could have called it just angle A or B or C. But a lot of times when you have an angle that you don't know, we call it theta. Everybody with me on that? So it's like a circle with a little swooshy thing through it. All right? So that's theta. So that's how I'm going to refer to it a lot. I don't even know if they do that in the book or not, but later on, you'll be using all kinds of little Greek letters. I mean, I tell you what, if you're ever a math major, by the time you finish being a math major, you probably have dealt with most of the letters in the Greek alphabet because the letters all stand for something in math. It's just amazing how many letters that they use in the Greek alphabet. What's one letter that you're very, very used to? We didn't, but Mrs. Bonsbach celebrated yesterday. Pi, right? Pi is a Greek letter of the alphabet, and it represents something, right? Oh, I'm sorry. I'm not that thrilled about Pi Day. It's just all right. All right, hush. So theta is a Greek letter of the alphabet. So what we're going to do is we're going to look at this. This side right here, we've already discussed that, but what is this side always going to be called? Why is it, or not why is it the hypotenuse, but what is the hypotenuse? How do I know this is the hypotenuse? It's opposite the right angle, okay? So this is always going to be the hypotenuse. It doesn't matter which angle I'm referring to, this one here or this one up here. This will always be the hypotenuse. But I put this angle and I mark this angle right here, and I'm referring to this angle. So if I wanted to talk about this side right here in reference to this angle, so if I'm starting at this angle, I'm like sitting right here at that vertex, okay, and I'm looking out among this triangle, and if I talked about this side, how would I refer to this side to this angle right here? Would I say it's like across from it? Would I say it's what? What do you think?
Adjacent.
Adjacent? This one right here? What does adjacent mean?
Adjacent means next to.
Connected to.
Right. Is this one connected to
It
this
would be that
angle?
one.
No, it's not. Okay.
Opposite.
It's opposite. That's right. This is right. And we've used that word. I thought you would get that right away because we've used that word a lot. We've talked about being opposite, an angle being opposite a side or a side being opposite an angle. Girls, come on. All right. So we've talked about that quite a bit. So this is actually the opposite. I'll just shorthand it OPP. You know what I mean. You guys don't even get that, do you? See, back in the day, I would have been considered pretty cool because that was actually a song. It was some song on a radio. I never really listened to it, but yeah, you know what I'm talking about? Yeah. Well, that's what they said in the song. But anyways, and now you guys don't even know it because it's kind of old. Well, anyway, this is
Realize we have
opposite.
about
Dominique remembers it.
5 minutes, right?
Oh, we got more.
No.
Not much more. That's okay.
We have like.
Well, if you guys would hush and let me talk, then I'd be able to finish. Okay, so look. This is opposite this. This side right here, again, according to angle theta right here, what is this side in reference or in relationship to this angle right here? This is adjacent. Adjacent is next to it. We've talked about that before. See, this side is connected to this angle right here, so this is adjacent. Adjacent just means next to, okay? Now, in math, we have several different relationships. Okay, not just three. There's actually 6 different relationships, but we're just going to talk in here about 3 of the different relationships. There's a relationship between 3 of the sides right here. Okay, there's pairings of the 3 sides. So one of the pairings, and I'm not going to go into a lot of detail right here, but one of the pairings is the opposite side divided by the hypotenuse. Okay. So there are times when I'm going to talk about the opposite side over, the hypotenuse. All right, and we have a word that talks about that. We'll write that in a second. All right. Then we also have a word that talks about the adjacent side to the hypotenuse, or the ratio of the adjacent to the hypotenuse. So we have these relationships or these ratios. And each of these ratios are going to help us out, and each of these ratios have their own name. So instead of saying, okay, look at the ratio of the opposite side to the hypotenuse, instead of saying that all the time, they have a word that represents the relationship between the opposite side to the hypotenuse. Does that make any sense to you? Okay. And the other one is, no, it's the opposite over the adjacent. Okay? And we have certain words that represent those particular ratios. So these things right here are just ratios of 2 sides of a triangle. And this one has a special word. And does anybody know what that is? It's the sine. And the word is actually sine, S-I-N-E. But just to shorthand it, we get rid of the E. Is that all right? Now, we don't say sin, though. Okay, it's written S-I-N. We use just 3 letters just to shorthand it a little bit. But we don't say sin. We still say sine. It's the sine of the angle. Well, which angle are we talking about here? We're talking about what? Theta. So you always take the sine of a particular angle. You have to know where you're starting from. You got to know whether you're talking about this angle right here or this angle up top. Okay? Does that make any sense? So if I'm talking about this angle, I'm taking the sine of the angle. Right? So that would be this opposite and this hypotenuse. Adjacent over hypotenuse is called the cosine. But we shorten that one. Now the sine's not really that much shorter, is it? It's just 1 letter left off of here. But cosine's a little bit shorter. So we just get rid of the INE. And let's scooch this over right there. And we're going to call this the cosine of the angle. So if I talked about the relationship between the adjacent and the hypotenuse, this would be the adjacent and this would be the hypotenuse. We call that the cosine. And what do you think this one's called? The tangent, right? And the whole word tangent is spelled like this, but we're just going to use the first 3 letters, okay? And then
Use the fraction and the decimal.
no, I won't use the decimal. And so we say it's the tangent of the angle. Everybody with me so far? I don't think I'm going to be able to finish this today, but at least we'll get a good start on this. So that's what we have. And you're going to have to memorize all three of these. You guys already spouted it off to me. Yeah, because if you look at this, watch, the sine is equal to, what was it? The opposite
OA.
over the hypotenuse. And then the cosine was equal to the what? Adjacent over the hypotenuse. And then the tangent was equal to the opposite over the adjacent. So in order to remember this, in order to memorize this, you came up with this little word. Doesn't really mean anything. It just sounds kind of cool, all right, if you say it real fast. So we say it's so, S-O-H, we say so, and this is ka, and this is toa. So SOHCAHTOA, SOHCAHTOA, all right? Sounds like some Native American tribe or something like that. SOHCAHTOA. All right, sounds pretty cool. It's like a greeting. So when you go in the hallway, see somebody else from our class, give them a SOHCAHTOA, all right, and then it's your little secret. You don't think you're going to do that? Come on, I want to see you doing that, okay? I want to see you doing that in the hallway. All right, no, do it to each other in the hallways. Slap five, give a high five, and say SOHCAHTOA to each other, all right? Then you can remember what these are, all right?
So we have no homework?
So watch this. Watch this. Let's say we got A, B, and C. There's a right angle right here. Here's a question they might ask you, okay? They're going to ask you something like this. They might say, find the sine of angle A. What is the sine of angle A? And let's do this. Let's put, I don't know, 3, 4, and 5, okay? So, right, sine, so, opposite over hypotenuse is what? Opposite, which is 4, and hypotenuse, which is 5. So if I ask you, and that's just an easy way, instead of me saying, what is the relationship between the opposite side and the hypotenuse to angle A? Instead of saying all that, shh, I'm still talking. Instead of doing all that, instead of saying all those words, you can just say the sine of A. And so if you told somebody that knows these relationships and the words, if you say, what is the sine of angle A? You know exactly what to go to because you know the sine represents the opposite over the hypotenuse. Does that make sense? What if you were asked the cosine of angle A? What would you say? It would be it'd be adjacent over hypotenuse, which is 3 over 5. Again, it depends on this. But what if I said, what is the sine of angle B? What's the sine of angle B? The sine is opposite over hypotenuse, so it's 3 over 5.
How do you put it in calculator?
Okay, we're not going to do that just yet. Okay, we'll do that a little bit. But let me just give you, you might not be able to do a whole lot of these problems, but do what you can.
We don't know how to plug it into a calculator.
I know, I understand that. I got done saying, I just finished saying that you may not be able to do all of these, but do what you can. Okay, so it's 5, 68, and 22 to 41. Do as much as you can. I know we didn't get to everything. I understand that. We'll finish that up tomorrow, though, okay? Because I have a day built in anyway. I was going to give you a worksheet tomorrow, but I can just finish teaching this and let you finish the rest of the homework. So that's section, what, 8-4.